Okay, section 2.2, subsets. Set A is a subset of set B, and this is symbolized by this guy. Notice it's like a C with a line underneath it. The C is facing the B. So when I read this, you have to put the thing that's the subset on the left. It's a subset of B on the right. So set A is a subset of set B if and only if all the elements of set A are also elements of set B. Okay, so if I have, well, we'll do the examples in a sec. Let me keep going with reading here. The symbol A is a subset of B indicates that A is a subset of B. The symbol A with a line through that thing indicates that set A is not a subset of B. Also kind of makes sense, right? Not, yeah. To show that set A is not a subset of set B, one must find at least one element of set A that is not in set B, okay? Let's look at the examples to see how this works, but I want you to note this right here. It kind of helps us later on. Again, to show something is not a subset of something else, all you need to find is one element in that set that's not in the other one, and it's not a subset, okay? So let's look at these examples. Determine whether A is a subset of B. Okay, I see A is 1, 2, 3, and B is 1, 2, 3, 4, 5. And I say, yes, there is every element in A is in B. So yes, A is a subset of B. 1, 2, 3, set A. B is also 1, 2, 3. Well, is every element in A in B? Yes. Is there any element that is in A that is not in B? Nope. So yes, A is a subset of B. And now I have A is 1, 2, 3, and B is 1, 2. Okay, all of a sudden I find an element right here, 3. Whoops, I didn't mean to scribble it out. I meant to highlight it. 3 is in A, but it's not in B. I found an element that is in A that is not in B. Therefore, no, A is not a subset of B. Okay, now we talk about proper subsets. A proper subset, A is a proper subset, and this is symbolized by a C without the line underneath. Okay, so it's this kind of stretched out C without a line underneath. If and only if all the elements of set A are elements of set B, which is kind of the same definition of the subset, but the set A is not equal to the set B. Again, let's look at an example. And I say 1, 2, 3 is A, and B is 1, 2, 3, 4. Yes, every element here is in there. There's no element in A that is not in there, so yes, A is a proper subset of B. Now here, 1, 2, 3, and 1, 2, 3. Yes, 1, 2, 3 is in there, but A is equal to B. Therefore, no, A is not a proper subset of B. It's a subset, but not a proper subset of B. 1, 2, 3, and 1, 2. Well, if it's not a subset, it's not a proper subset. Okay, so right away I can say, nope, I see this again, the same 3 that we had highlighted before. That's an element in A that's not in B. Okay, so the difference between a proper subset and a subset is that equals to. Okay, if they're equal, they are not proper subsets of one another. Okay, one may only be a proper subset if every element is in from A is in B, but they're not equal. Okay, set A is a subset of the set B if and only if every element of A is also an element of B. If A is the empty set, then A has no elements. Okay, so if A is the empty set, let's write it down. Oh, it's over here. That's okay, I'm gonna write it again. Okay, there are no elements, right? No elements. Okay, and so all of its elements, none of them, there are none, belong to B, no matter what B we're dealing with. Okay, what the heck does that mean? It just means that the empty set is the subset of every set. Because remember how I pointed out this important sentence? One must find at least one element of A that is not in B. Well, if there's no elements in A, there's definitely not something in there that's not in B, because there's nothing in there. There is not an element in A that is not in B. Okay, so consider the sets. A, empty set. B, 6, 7, 8. Is A a subset of B? Yes. There is not one element in A that is not in B. Okay, so this one's tricky for sure. A really nice way to just remember it is that, nice way to just remember the empty set is a subset of all sets. So I look at this, and if someone says A is an empty set, is A a subset of something else? The answer is yes. Okay? Yes, because every single time the empty set is a subset of all other sets. Okay, so the number of distinct subsets of a finite set is a formula, is 2 to the n, where n is the number of elements in A. Okay? And the number of distinct proper subsets is defined by 2 to the n minus 1, where n is the number of elements in set A. Okay, so let's do an example so you can see what this means. Okay, let me move this. First, determine the number of distinct subsets of the set 4, 6, 8, 10, and then list them all. Okay, so before listing, I'm just going to actually use the formula. I'm trying to say how many, oops, I did it in red. How many subsets are there in this set A? I use the formula 2 to the n, and n is the number of elements in this guy. So how many elements are in here? 1, 2, 3, 4. N equals 4. So I plug in 4. And 2 to the 4th is just 2 times 2 times 2 times 2, which tells me 16. There are 16 distinct subsets in set A. Now, you could have listed them first and then counted them up, which is all fine and good, except when you get to a really big set. If I give you a problem like this, 1, 2, 3, 24, do I really want to list all the subsets of this? Heck no, I just want to use the formula, okay? I just want to say 2 to the 24th is whatever it is, okay? And obviously that's a huge number. But now for this guy that only has 16 subsets, I can draw it out for you, because if I draw it out for you, you can count them and see them. So what are the subsets of A? A equals 4, 6, 8, 10. The subsets are 4 is a subset, 6, 8, 10. There are 4 of them. And now how about subsets of 2? 4 and 6 are in there, right? What about 4 and 8? Sure. 4 and 10, yep. And then how about 6 and 8? 6 and 10. And finally, 8 and 10. Okay, it's a little tricky to get them all down, but we're doing subsets, meaning they have to be elements in the subset that are also in the set. So now let's do groups of 3. How about 4, 6, 8? Or 4, 6, 10? I don't know why I read 6 first. And how about not 4, but 6, 8, 10. And I wrote a comma up here for no apparent reason. Okay. 6, 8, 10. And 4, 6, 8, 4, 6, 10, 4. What about 4, 8, 10? Okay. Very easy to miss one, huh? Don't worry, I won't give you anything bigger than 4 to do. 4 elements. Now, if I count this up and I say, okay, these are all the subsets, I can see that I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, wait, I only have 14. I'm missing 2. And I say, oh, right, subsets. The entire thing is a subset, right? It's not a proper subset, but it's a subset. Sure. So now I have 15. I'm missing one. What's the one that I'm missing? Oh, right. The empty set. The empty set is a subset of all sets. Okay, so the listing that I did here, well, it's super handy in actually breaking it down with the elements, but then it's pretty easy to forget the entire set, the whole A, and the empty set. So try to remember when we talk distinct subsets, it's not just the ones that are less than the whole set, but it's the entire set A and it's the empty set every single time when I talk about distinct subsets. And now it says determine the number of distinct proper subsets. Proper subsets for the given set, the same set. What's the difference? Okay, well, remember our formula. The formula for a distinct proper subset is this. Well, it's still the same 4. And I say it's 16. Okay, so there's 15 of them here. So of these 16, what's the difference, right? And you might recall the difference between a distinct subset, let me get some red, distinct proper subset, proper subset, that's the key word, not the distinct, they're both distinct. The proper subset says A can't equal B, right? So this guy right here that counted as a subset of A, it doesn't count as a distinct proper subset. So 15 is all the same up here, all from A, part A, except the entire one, 4, 6, 8, 10. The entire set A. Okay, that's the difference between the number of distinct proper subsets and the distinct subsets. Okay, moving on to the next page. Consider the sets. I've got A, 11, 12, 13. I've got B, 11, 12, 13, 14, 15. I've got C, 13, 11, 12. Okay, so now I've got a whole list of questions here. Is A, now start reading these to yourself out loud. Remember that, first of all, this means a subset. This means a proper subset. Okay, so is A a subset of B? Yes, every element in A is in B, and there's no element in A that's not in B. So yes. Right, we see 11, 12, 13, 11, 12, 13. Yep, they're in there. And there's 2 more in B, but that's okay. A is a subset of B. Now, is A a proper subset of B? Again, that's just saying, are the elements in A and B, but they're not equal? Well, that's also true, yes. There's 2 extra elements in B that are not in A. Great. Is A a proper subset of C? Well, I say 11, 12, 13, 11, 12, 13. Yep, that looks good. That's good too. Now, is A proper subset of C? Well, I noticed that A equals C. Therefore, no. A is not a proper subset of C. Is C a subset of A? Well, are all the elements here? 11, 12, yep, that looks good. No problem. Is C a proper subset of A? Nope. C is equal to A for the same reason. This was a no, this is a no. Is B a subset of A? No. I see 14 and 15. Those are in B, but they're not in A, so no. B is bigger than A, right? The number of elements in B is bigger than the number of elements of A, so it's not possible for it to be a subset. Is B a proper subset of C? Again, no, because the number of elements in B are more than the number of elements of C. Is A a subset of A? Yes, A is A, but they're always, we noticed in our example before, yeah, if they're equal, as long as it doesn't say a proper subset, we're good. And speaking of which, here it says, is A a proper subset of A? No, because they are equal. A equals A. Okay, example 6, true, false. If false, give the reason. Okay, now I'm bringing back the symbol This E, remember this is red, is an element of. Is an element of. Unlike this, which means is a subset. Okay, so let's read it correctly. 4 is an element of the set 3, 4, 5. Yes, I see it. There it is, in there. There it is. It's an element in this set. The set 4 is an element in 3, 4, 5. Now you might say, well, yes, there's the 4. But no, this is a set. This is a set. This means is an element of. The set isn't an element of. Okay? The set is a subset, sure, but not an element of. So no, this one is false. And I should be careful. This is true. We're not saying yes and no. We're saying true and false. Now, the next one, the set 4 is an element in the sets, the set of 3, the set of 4, and the set of 5? Yes. Now, this is a set, but so is this. Okay, so in this case, the set is also an element. Okay, a set is an element of a set of sets. So this is true. Now it says, next one, D. The set 4 is a proper subset of 3, 4, and 5. So yeah, it's a set. So it can be a subset, and it can be a proper subset because it's not equal to the set. So that one's also true. Now it says, the element 4 is a subset of 3, 4, 5. This, without the braces, is an element. And an element can't be a subset, can it? So this one is false. The element 4 is not a subset. And now the next one. The empty set is a subset of 3, 4, 5. Yes, right away, true. The empty set is a subset of all sets. We know that, okay? Empty set is a subset of any and all sets. Okay, so now I say the empty set is an element of 3, 4, 5. No, that's not right. I didn't say an empty set is the element of any set. I said it's a subset of any set. This is false. The set 4 is a proper subset of the set 4. Also false. That's not true. Why? Because the set 4 equals the set 4, and therefore it is not proper. Okay, next one. The set 0, the set of the elements 0 is equal to 0. No. This is a set with the element 0 in it. This is just 0, the element itself. Okay? Again, one's a set and the other one is just the element. So this one is also false. The empty set is a subset of 4. Well, just like here, the empty set is a subset of any set. True. And I think that is it for this section. Yes. Okay. So take your time on these, guys. I'm a bit repetitive in doing so many of them is because I want you to learn how to read it and read it properly. Okay, so take your time, understand the difference between the subset and the element and the proper subset. Okay, on to 2.3.